This is the 4th edition of the Digital Design Weekend, a big annual event here as part of the London Design Festival, celebrating contemporary digital art and design. This year's theme is collaborations in art, design and science, and the event includes many exciting projects between artists, scientists, designers. We have the Hackathon, we have the Met Office, many people from NASA as well, and bacteria, biotechnology and other exciting projects around science and design.
One theme that we were really keen to explore this year was the fact that design is everywhere and make design as accessible to the public as possible. So you've seen that across our branding, our kind of identity where design is here, there and everywhere. So I think the museum is a great environment to try and communicate this message that design is for everyone.
Okay, so what are we doing here is one of the questions that the public have been asking me. My name's John Rogers, I'm from the University of Dundee, and I run a studio around making intangible tangible, so things like data, the internet and notions of climate change, and bring them into our world in a physical way. One of the ways that we believe that can happen best, it's not the answer, but it's the way it can happen, is to do these collaborative making events. So what you can see around you are all these people kind of doing different things, but together. This is kind of a hackathon, but I prefer the term collaborative making. So we've brought together the Met Office, who have incredible resources on data and are managing to tell that story to us through science of climate change and its effect on humanity. We have Helen's Story and her Fashion Institute who are very interested in sustainable fashion. What happens when you put those two great minds together in a room and lock them in for 36 hours in the Victoria and Albert Museum? What will happen? Well, I have no idea, and nor do they, but we do know there's tons of energy, there's tons of things happening, and we are going to make them do something physical that tells a story that responds to climate change. If I could just introduce you to, if I could introduce Dr. Justin Marshall, who is from Falmouth University. He's one of the world's experts in how you craft physical things using digital production techniques.
So, kind of in this mix of this hackathon, I thought it would be really useful to have the ability to make things using digital tools, but not perhaps from that kind of perspective of design engineering, where all these kind of digital production tools have come from. Historically, it's more about taking a crafted approach to, okay, what can these tools do for us in a kind of hands-on way? How can we get the characteristics of kind of rather inert plastics to do something exciting and interesting and engaging for people? So I suppose it's taking a tool set that has been developed for one particular set of applications and looking at how it might work for a broader set of people. And hopefully in this whole kind of mishmash of people, we'll have these the ability to kind of add extra value and extra materiality into the mix when we actually produce these prototypes.
So bringing these tools in of rapid digital production that can create these physical artifacts into this making environment, we're also able to tell that story to the public, because most people now have started to hear a glimpse of 3D printing and they might have seen that gun, but what does it actually mean and what does it do? And there's something wonderful about setting the 3D printer here against the sewing machine here. I mean, if you look at a sewing machine, it doesn't actually look that different, because it's been with us for 100, 200 years, whereas the 3D printing has been with us 10 or 20 years, and it's only in the last 2 or 3 years that it's become down to a domestic price and domestic kind of setting. So what does it mean for the 20,000 visitors that might pass through here to understand that technology and to see it in a living way? Adding to that sense of what we can physically make is the exciting proposition of what can we make interactive? How can we take digital technology and connect it into the physical world? Ross Atkin over here is playing with various devices to do that. So this device here is the electric imp. The electric imp enables you to connect anything physical to the web anywhere. It connects the data on the cloud and can control motors, it can control lights, it can control screens. It can do stuff in the physical world from just this tiny SD card shape. Technologies like these are going to become commonplace. So when we put them in a public hackathon, we can start to communicate what it means to have absolutely everything. Maybe your shirt connects to the internet, maybe a piece of paper connects to the internet. And what that means to climate change, well, yeah, again, we don't know, but we're going to see this thing evolving over the weekend.
So my name's Helen Story. I'm here as part of Centre for Sustainable Fashion, and the piece that I'm working on is called the climate dress. In fact, we've decided 2 minutes ago we're going to do 2 or 3 of them. One dress is going to alter its coloration in line with temperature change on the planet, and the second dress is going to be the beginnings of a new way of communicating between people. So your clothes are going to be able to project what you're feeling, messages that you want to convey to other people, and stream world news. The idea is that when we get to the next sort of climate summit 2015, that anybody who is there is able to show indignation or show support, but all over their clothing. So it's amplifying human voice into textile form. So this is the room that we're all working in, and around each table is a different idea and a different challenge that's being explored. Everybody comes at it from a different angle, but they've all got one goal in mind. This is a very, very early scribble of the idea of being able to house some kind of jewelled piece. At the moment we are stuck in gadgetry. I hope one day we can actually get textile surfaces to be responsive, but for the moment we're still involved in gadgetry. Within this jewelled piece there will be both the facility to wirelessly receive messages and a projector, a tiny mini projector, which will then flood down the dress. So the dress in effect becomes a canvas for information and, in this case, human emotion.
Hello, I'm a scientist from the Met Office. I work in the climate science area, particularly in looking at how people can adapt to climate change. For this project, for this hackathon, I'm going to be involved with the challenge that is trying to make a climate dress. So the goal is to have a garment that we can project some kind of climate data onto it. The current idea is that maybe we could get sea level rise projected as it over time, as it rises up in our climate data series. This could be projected onto a dress, and it gets further and further up the dress as time goes on. Another idea we've had is that we could somehow visualize change in temperature on a dress by changing the color. So as a model walks down the catwalk, her dress can change color depending on how far along the catwalk, which we are using as our sort of measure of time. So she gets to a much brighter color at the end of the catwalk, representing the increase in temperatures. At the moment, my first goal is to get some climate data and to process that into something that we can project onto this dress, while my colleagues on this challenge are going to be actually putting together the dress itself.
My name's Ollie Palmer. This is a piece called Nibble. The idea behind this is that before the first computer that could actually play chess was invented, Alan Turing built the first chess computer program, and he played the entire program as if he was a computer, piece by piece, kind of making every single move as if he was a computer program. And each one of these dances represents half a byte of information. So they're working together to become a human computer. All 4 of them, the directions they face represents a line in a code, and the position they're in represents a column in a code. And this is an ASCII lookup table. So it's the same type of thing that every kind of mobile phone or computer or whatever uses to look up what characters are displayed. And over the course of 45 minutes, the dancers have a signal put into their ear. They're all wearing little earpieces. They're told to move to specific positions. And this is conveying a message that takes 45 minutes.
delayed reaction.
And it reverses whatever you put in.
Are you involved in this installation?
No.
Oh, no, I just. Oh, okay.
Each one is a different machine.
Okay.
It behaves differently. This one's also upside down, so it kind of gives you a clue what it does. There's one with a machine, with a wheel on it. That one very short. Oh yeah, this one. Yeah. So this one, when you put it in, it comes out there.
My name's Kelly Snook. I'm with a company called Co-Design, and we're here demonstrating the Makey, which is a little circuit board that you'll see right down there, and it emulates a computer keyboard. So we have a number of different demonstrations showing what the Makey can do by completing a circuit, like any kind of circuit that we've made here. I've made a circuit between the ground and different drums, and those are mapped to different sounds. And some of our other demonstrations involve sound as well. We have tongue twisters mapped to pieces of paper that if you touch the different words, you hear the different words. And then we have a piano made out of fruit. So that's what we're demonstrating here, different things that the Makey can do. Oh, I see.
Peter, woodchuck, the...
My name's Michael Takeo Magruder. I'm the artist that's leading the DataC project. This work is about the relationship between broadcast media and astronomy. And the idea for the piece really centers around the notion that when science began, we of course had a very Earth-centric, a human-centric view of our place within the stars. And over time, we realized that that was not correct, of course, that we're just a small speck in a wide, vast universe. But then, of course, art is often about bringing things back to humanity. And on that idea, what I wanted to do is I was looking through science, and in astronomy, there is still one example where we are the center of the universe, and that's with the concept of the radiosphere. So in 1941, our media transmissions were strong enough to escape into deep space. From that point on, those transmissions would travel at 1 light year per year into space, traveling throughout to infinity to reach other star systems. So this artwork tracks all of the star systems in the 73 years since that point in time that our media signals have actually traveled to. So it creates this real-time virtual sculpture that people can navigate through. You can experience in different ways on a screen or in a large mobile planetarium dome like what you see behind you. And actually it's a merging of the art, science, visualization, and technology sort of all coming together to make this particular experience for people here at the V&A today.
My name is Dr. Joanna Jarvis. I'm a professional astrophysicist. My involvement with the DataC project has been very much maintaining the scientific accuracy of the work. Obviously over the last decades we've collected an awful lot of information about the universe around us, the positionings of objects, what objects are, how bright they are in our night sky, and indeed, perhaps most interestingly, the existence of exoplanets, so planets in orbit around other stars local to the Earth. So all of those are actually portrayed within this piece of artwork, thinking about the communications from the Earth that those stars, those exoplanets, and therefore potentially other civilizations, other life forms are going to be receiving from the Earth. We can actually move our way out through this piece of artwork, stepping out slowly. At this point we come right the way out to the edge of what we refer to as the radiosphere. So since we started broadcasting from the Earth, this is basically the outer limit of where all that data has gotten to, where that information has come. And then just to give us the biggest picture of possible, right out here at 150 light years, we're way beyond Earth's radiosphere at the moment. We haven't had any influence over this area of space yet. It will happen because there's nothing to stop our communications from just continuing infinitely through space.
So my role in this project is to mediate between the artist, the scientist, and the eventual realization of that in the dome. So what I've done is I've taken all of those different stakeholders and started to build up the different forms that we need. So as we've been talking about the different components, my job is to encode all of this, both graphically and within the actual code sections, to make it realizable.
This is the B-Lab Citizen Science project. This is a collaboration between Technology Will Save Us, Horizon Digital Economy, the BBKA, the British Beekeeping Association, and myself, Rob Phillips, a PhD candidate. What we're looking at is using open design to create beehive monitoring devices to then distribute throughout the UK so that we can get an idea of what's happening within bee health. The idea of citizen science is people gathering data about a specific area or a specific thing, engaging the public or people throughout the world. The idea with this particular project is that the beekeepers are already interested and motivated in finding out what's happening within their hives, so that then throughout this process they can donate the data to the charity, the BBKA, and then also to other data streams, so that alternate people, alternate entomologists can learn different behaviours, different aspects about what's happening within particular geographic areas. One of the most important things within beekeeping is understanding the weight of the hive, the health of it, the temperature, the humidity, because these all correlate with different diseases that can occur. One of the elements that we're trying to do within this project is start to explore how we can include the public in citizen science through open design. So by people making different interactions within a broader spectrum. The only problem with opening things up to the public is sometimes this is open to abuse or open to tailoring. So this is also a research project looking at how this wider area is going to work and learning lessons that we can apply to different areas of wildlife and commitments throughout the world. So this is version 1 of our kit. Technology Will Save Us have created a really beautiful PCB that has a prototyping area. So the intention is that we have a base unit that monitors the hive weight, the feeder weight, or a particular bar weight of a hive, then also the temperature and the humidity. But this is not an Internet of Things project, but it could be built upon as an Internet of Things project. The main reason is because hives are usually in really remote areas, so they would be quite hard to get connectivity. And if you put a 3G module on it, it would cost a lot more, so we would be able to produce less kits throughout the project. But throughout the open design nature of it, people will be able to build on the back of it and adapt it for their own needs. So we're starting at a lower threshold so that we can engage more people rather than creating the Uber kit that then is a lot more expensive and basically engaging a smaller group.
My name's Alistair McClymont. This piece is called Raindrop, and it began with a conversation with a scientist from the meteorology department in the University of Manchester, and he'd made a machine that did something very similar in order to research raindrops and the charge on raindrops. But what I saw the machine do, I thought was incredibly beautiful, keeping a drop hovering like this. So I got in touch with him and he sent me his research paper, but the only information I got really was a doodle of the piece. It's a very tiny picture with no dimensions on it. So I spent a couple of years playing around remaking this machine, but essentially what I've ended up with is a continuation of this experiment that began in Manchester. But for me, I'm just interested in that raindrop that's like a little hovering jewel staying there. The piece doesn't really exist on its own. It does require a human to be there, and this human needs to replace the raindrop every now and again. So it is an interaction, and it is, if you like, an ongoing experiment.
Here you are in the middle of the presidential suite, and Mr. the President, from France actually, has just been finding out that there is an asteroid which is going to impact on Paris, which is kind of a big deal. And he thought that he was going to invite all the top world leader scientists who knows about asteroid impact to actually come and brainstorm on what do we need to do. And so they are currently discussing and debating on what sort of disaster mitigation and procedures they need to put in place to evacuate or not evacuate the public. And then of course they discuss ethically, do we need to even bother? Shall we, if Paris is wiped out, then that's fine if the rest of the world still survive. And there is all of these elements that come and take part in the discussion, and of course the budgets that come into it. So for example, just to give you a bit of insight on what we could do, we could paint half of the asteroid in white reflective paint, and that's real solution which have been designed for it. And if you do that, then that's supposed to slow down the entry of the asteroid into basically the Earth and eventually avoid the impact. Or there is another solution which is called kinetic impact, where you will send a spaceship to actually attack an asteroid, and that will sort of stop it or explode it in many different parts before he enters into Earth. Or there is a nuclear one, which is the last one that has been thought through, where you can just blast a bomb at it and hopefully, modify it from coming into us. So they are discussing which one of these will be the best suitable. But then the problem, of course, is that we never tried this procedure. So what do we do? And that's all part of a bigger project called Disaster Playground that I'm doing and I've been starting to do. And that project is launching it. And it's all about basically catastrophe and disaster and planning for these things as part of the space program.
So we're doing an MRSA quilt making workshop today. I'm the artist on the Modernising Medical Microbiology project, which is looking at the implementation of whole genome sequencing across the health service. And what we're doing today is making an MRSA quilt. So I've made these previous pieces here. The squares of bacteria, the squares of fabric are embroidered with natural and clinical antibiotics and then embedded in agar plates, such as this, which is a selective agar that only grows Staphylococcus aureus bacteria, and when it grows it turns blue. So you embed the textile in there and we grow it, and where the antibiotics are, it creates a pattern on the bacteria, and then we grow them for 18 to 24 hours, and then we autoclave them, which is a high pressure steam sterilization technique, which means that we can then exhibit them to members of the public. So it's a really nice way of having conversations about bacteria and about microbiology, and for people to get a chance to meet scientists. I'm an artist, but I'm here with two scientists today, and it's a really nice chance for people to actually sit down and chat to scientists about their work and about these issues in microbiology that affect everyone.
Once all these pieces are finished here, we take them back to the laboratory where I will seed them with MRSA and Staph aureus bacteria, then I'll culture them and then once they've grown up and sort of created the artwork, then I'll sterilise them so that they can be displayed in public safely.
It's quite hard to have a conversation with the public about bacteria, and it's even harder to have a conversation about the big revolution in technology that's going on at the moment, which is around looking at the whole genome sequences of bacteria, which is part of a network project we're involved in Brighton, with other centres across the UK, Oxford and Leeds and Birmingham, and with Public Health England, with the idea that we can use the total DNA information of a pathogen to tell us about what species it is, how closely it's related to other members of that species, so that we can study outbreaks or study transmission, and also to determine whether a particular strain is resistant to antibiotics, so we can use it as a diagnostic tool in a laboratory. So it's probably ridiculously optimistic to think that at an event like this we can start having that sort of conversation, but ultimately we do need to have that sort of conversation, because the level of information that we're going to get from the new DNA technologies is going to be very revolutionary at all sorts of levels.
Hi, my name's Neil and I'm here with Code Club, and I'm spending the day at the V&A teaching kids an introduction to coding, teaching them to program using a language called Scratch, which was developed by the Media Lab at MIT. And it's what we use in our after-school clubs that we run across the country to teach kids the basics of programming and get them interested in the subject, and hopefully turn them into the developers of the future. And today I'm using one of our sample notes for a game called Whack-A-Witch, and we go through the process of creating the game from the very basics of getting the witch on screen and making her move, and then all the way through to being able to click on the witch and keep score of how many times you click on the character, and add a timer so that the game doesn't go on forever, and you try to click it as many times as possible. And that's what we do, and that's what we teach. So Code Club is a volunteer-led organisation, and it runs after-school clubs for 9 to 11-year-olds across the country and across the globe.